So let's start off with VLAN configuration. VLANs provide layer 2 separation boundaries for unicast, multicast, and broadcast packets. 4094 VLANs can be configured, and that's per VDC. Some other notes about VLANs just in general. VLAN 1 is certainly the default VLAN, and that cannot be deleted. Once you create a VLAN, it automatically goes into an active state. You can use the shutdown command to disable a VLAN. NXOS also has a series of reserved VLANs, and these reserved VLANs are used for various features internal to the system. And prior to NXOS 5.2.1 for the Nexus 7000, this VLAN, reserved VLAN range was between VLAN ID 3960. Prior to NXOS 5.2.1, this reserved VLAN range was between 3968 and 4094. Now, after NXOS 5.2.1, that user-defined VLAN range is now configurable, so you can change that if that would happen to collide with a VLAN that was on your production network. So as you can see here in the slide, I've gone through some configuration elements of creating a VLAN. So in config mode, to create a VLAN, you simply type the command VLAN and the VLAN ID. Now, one of the other things that I like to do from a best practice standpoint is to give all of my VLANs a name. You can see here that that command is just name, and then whatever name you want to give that particular VLAN. It's just best practice. You can also see that you can create a range of VLANs using the dash in between them. You can also use a comma if the range is not contiguous. So to verify that your VLAN was created, the command is show VLAN, and you can see here that we've created VLAN 10. Its name is email VLAN. It's active, and here's a port that's active on that particular VLAN. So next, a little bit about VTP, or the VLAN trunking protocol. All VTP packets received on the Nexus 7000 by default are actually dropped. So if you have VTP in an existing network and you insert a Nexus 7000 into that environment, the Nexus 7000 will actually drop the VTP packets. So you do need to enable VTP in transparent mode to extend the VTP domain through the Nexus in this case. And it's also important to note that VTP packets received on a trunk port are relayed to other trunk ports. So as most items in NXOS are, VTP is a feature, right? You turn it on with the command feature VTP. You set a VTP domain name and then change the version. It's important to note that version 1 is the default. The command to verify this is show VTP status, and as you can see here, I have a wealth of information about VTP running now in my environment. Now, a little bit about private VLANs. And first, we're just going to talk about them from a high-level introductory standpoint. So, private VLANs, or PVLANs, offer a mechanism to divide a single VLAN into multiple isolated Layer 2 networks. PVLANs can be configured on a single Nexus switch or extended across multiple devices by trunking all the primary isolated and community VLANs to other devices that need to participate in the domain. Some other things to note about private VLANs: they consume the existing VLAN range, so the primary and secondary VLANs will consume the available VLAN ID pool. A private VLAN is ultimately an association of what are called primary and secondary VLANs, and we'll get into that in a little bit later on. And when we talk about some of the configuration aspects, I'll go through what needs to be configured and enabled prior to using private VLANs. So within a private VLAN domain, there are two major types of VLANs. There's a primary and a secondary VLAN. So the primary VLAN is where the broadcast domain is defined. Promiscuous ports, which we'll talk a little bit about as this session continues, are part of the primary VLAN and communicate with all the other ports in the primary VLAN and the isolated and community ports. Secondary ports are subdomains that share IP address space with the primary VLAN, but are isolated from each other in one of two ways: isolated and community VLANs, and we'll talk a little bit about those next. So as I mentioned earlier, there are two types of secondary VLANs. The first is the isolated VLAN. So Each port within an isolated VLAN is restricted such that it can communicate only with promiscuous ports in the primary VLAN. Ports within the isolated VLANs cannot receive broadcasts from other devices within that isolated VLAN. So think about every device in that VLAN being isolated from one another, but being able to talk to the promiscuous port. I'll give you a graphical example in the next slide so it will make more sense. The second type of secondary VLAN is a community VLAN. So community VLAN ports are restricted from communicating with other community VLANs, but might communicate with other ports in the same community VLAN and promiscuous ports belonging to the primary VLAN. So essentially you create communities, and within these communities, ports within the same community can talk amongst each other, but not with another community. Multiple secondary VLANs can be associated with a single primary VLAN. These associations ultimately define a private VLAN domain. So here's a graphical overview of the VLAN types. Up at the top, you see a primary VLAN. We'll call this VLAN VLAN 2, just as a quick example. Our community VLAN in this case is VLAN 10. We have an isolated VLAN 11 and a community VLAN 12. So we'll talk about isolated and community VLANs a little bit more in detail here. So a community VLAN, if you look at this particular graphical example, we have two different community VLANs defined, VLAN A and VLAN B, with the promiscuous port on our primary VLAN. So ports in community VLAN A can talk amongst other ports within that same community VLAN. However, a port in community VLAN A cannot talk to a port in community VLAN B. But both ports in community VLAN A and community VLAN B can talk to the promiscuous port in the primary VLAN. Now we'll talk a little bit about isolated VLANs. So again, we have the same setup. We have an isolated VLAN A and a community VLAN here. Again, as we discussed earlier, ports inside of this community VLAN can talk amongst each other and also to the promiscuous port. However, ports in this community VLAN cannot communicate with ports in the isolated VLAN. And furthermore, ports within an isolated VLAN cannot communicate amongst themselves. So this offers a way to isolate individual layer 2 elements within isolated VLAN from being able to talk or send broadcasts amongst each other. This isolated VLAN, however, can communicate with the promiscuous port that exists on the primary VLAN. So now let's get into some CLI for private VLANs and look at what a sample configuration might look like. So now we're going to get into some of the configuration elements for private VLANs. Again, due to the modular nature of NXOS, we do have to enable the feature first. So I'm going to go into configuration mode first and foremost here, and I'm going to enable the feature for private VLAN. So we'll give that a second. Now once that feature is enabled, we're going to create several VLANs here for the purposes of this demonstration. The first VLAN that we're going to create are isolated VLANs, so one of the secondary VLANs. We're going to call this VLAN 101. So first we'll configure that VLAN, VLAN 101. As I mentioned earlier, I like to give my VLANs names so I can refer to them later. So we'll call this VLAN the isolated VLAN. And then we'll configure this VLAN as an isolated VLAN. So that actually then configures that VLAN as an isolated VLAN. Next, we're going to create VLAN 102. I'm going to name this one our community VLAN, and we're going to use this as our community VLAN. And I'm also going to configure this now as a community VLAN. Last, to complete our private VLAN domain, I need to configure the primary VLAN. So we're going to call that VLAN 100. I'm going to give it a name as our primary VLAN, right? And I'm going to say that this is private VLAN primary. So once that's done, we now have to associate our isolated and community VLANs to our new primary VLAN 100. We do that with the command private VLAN association add, and then we're going to add our two secondary VLANs, 101 and 102 in this case. So this is going to complete our private VLAN domain. Now we actually have to configure the interfaces. So I have some hosts connected to this Nexus 7000. The first hosts that are connected to this 7000 are on Ethernet 121 and 122. These hosts are hosts that I'd like to place in the community VLAN. So I'd like these two hosts to be able to communicate with one another. So first, I'm going to go into interface Ethernet 121. I'm going to give this port a description. I like to give all of my ports descriptions as well. So we'll call this host 1, and he's a community host. We'll set this as a switch port. We'll set this switch port as mode private VLAN host. We're defining this as a host port. Next, we'll go into Ethernet 122, where I have another community host. We'll give that a description as host 2-community. We'll set this as a switch port. And again, we'll set this as switch port mode private VLAN host. Now I have two hosts plugged into Ethernet 125 and Ethernet 126. These are the two hosts that I'd like to keep isolated, so hosts that I don't want to be able to broadcast to one another. So first and foremost, I'm going to go into interface Ethernet 125. I'm going to set this as a description host 3, and we'll call this our isolated host. We'll set this as a switch port. Again, we'll set this as switch port mode private VLAN host. And we'll do this again for our other interface in Ethernet 126. This time we'll configure that called host 4. It's a switch port again, and switch port mode private VLAN host. So this completes some of the basic port level configurations. Now, the next step that I need to do is actually bind the private VLAN host associations back to our primary VLAN. So because NXOS makes this pretty smooth, I'm actually going to configure two of the ports at the same time. So I'm going to go into interface Ethernet 121 and 22. Now I'm going to say switch port private VLAN host association. Right now my next step, as you can see here, is to specify my primary VLAN, which we configured earlier, which is VLAN 100, and now my secondary VLAN. So this is for this particular one in 121 and 122 going to be our community VLAN, which was 102. So I'm going to specify that there. Right? Now I'm going to go into interface Ethernet 125 and 26, right? Because I like to type as least as possible, I'm going to hit the up arrow here, and I'm going to run that same command, but instead of binding it to the community VLAN, I want these ports to be bound to the isolated VLAN. So I'm going to switch it from VLAN ID 102 to 101. I'm going to do that. And that completes the configuration required to configure host ports for private VLANs. Now that we've completed the configuration task for host ports in our private VLAN domain, let's verify the operational status of these host ports. So the best way to do that is to run the command show VLAN private VLAN. And this is going to give us some very detailed information about our private VLAN domain. Right? So you can see our primary VLAN here, which is VLAN 100, and then our two secondary VLANs, VLAN 101, which was our isolated VLAN, and VLAN 102, which was our community VLAN, and of course the ports that we configured and associated to this particular private VLAN domain. So this gives you a good idea, again, of how to verify the operational state of private VLANs in your environment. So now that we've configured all of our host ports, both isolated and community hosts, as part of our private VLAN configuration, I want to illustrate a sample configuration for the primary VLAN, or our promiscuous VLAN in this case. And to do this, we're simply going to create a layer 3 SVI. The first step here is to create that SVI, and we're going to call this interface VLAN 100. Of course, this corresponds to the primary VLAN that we've been using in this example. So I've created that VLAN. I'm going to give it an IP address, and we'll just use a dummy address here in the lab. So we've given that particular SVI an IP. And now I need to bind that SVI again to our isolated and community VLANs. So I'm going to do that by private VLAN map. And then again, we're going to add our isolated and secondary VLANs, 101 and 102. So that will complete that. And if we quickly do a show running config of that interface, you can see here the IP address and the private VLAN mapping for our isolated and community VLANs.